Hello guys. Hello guys, good evening. I'm Yogendra Kumar, a mathematics teacher at askIITians. Okay, so we are doing today third lecture on polynomials. I hope you have watched previous lectures. Okay, previous lectures. Yeah, already three lectures are done. Okay, on this chapter. So this is fourth actually, basically. Yeah. So I hope you are watching regularly so that you are understanding in a sync. Okay, like all the previous topics are clear, then you're coming to this topic, so it'll give you clarity on the all the topics if you're doing this way, right? Because the last class we did practice, and before that we did factor theorem, remainder theorem, splitting middle term for a quadratic polynomial. So those are really important topics, okay, in this chapter. So you need to watch those before coming to this lecture, right? So let me start today. Let me start now with this particular topic, okay, here, which is what we are going to discuss in numbers in this polynomials, algebraic identities, division of polynomials, right? These two topics we will be covering. Okay, so let's get started. Right, you already know the weightage of this chapter. I discussed in the previous lectures. It comes for 8 to 9 marks, right? It is really important chapter, and these topics are really important because their uses are there in other chapters and all, right? So I hope you are understanding the importance of this particular chapter. I told already that this chapter is there in 10th grade also, so you need to really pay attention to what I'm saying and to what I'm explaining, right? You need to get the clarity on each and every topic. Make sure you understand mathematics in conceptual way, not by hearting stuff. It is not, mathematics is not just by hearting, it is for understanding, right? So let's get started. Okay, we are starting algebraic identities, right? So first is what algebraic identities and an algebraic equation that is true for all the values of variables occurring in it, right? So this is what first identity you can see here. X plus, very basic identity, x plus y whole square is equals to x square plus 2xy plus y square. I hope you know already this, right? And you should know how it is coming. We need to remember, obviously we need to repeat it like many times for the we are already using it and we will be using it further, right? So we need to remember it. Okay, and we should know how it is coming. It's not like just okay, it we feel to, yeah, if I say we feel to write okay x square, like you might have heard okay Modi ji also saying okay x plus a plus b whole square is what a square plus b square. Then from where this 2ab is coming, right? That is extra, right? It looks like extra, but I think we need to understand that how it is coming, right? We can verify as it is written above that it is true for all the values of the variables, right? So identity, what is an identity? It is true for every single value of variable, right? This is what you need to remember. So let's verify this. Okay, basically it is what x plus y whole square is nothing but x plus y into x plus y, right? So what we do actually, this x will be multiplied to x and this will be multiplied to y. So that is going to give me x square plus x into y is what xy. Then y will be doing the same thing. Okay, y is going to multiply here and y is going to multiply here. So xy plus y square. Now you can say like, sir, it should be like yx, not xy. That is same thing actually, right? Multiplication is commutative, right? AB or BA, that is same thing only, right? So what are we getting? X square and like terms, these xy. They're like one chocolate plus another chocolate. How many chocolates? Two chocolates, right? Okay, we can say like that xy is what? 2xy plus y square. This is how we get this identity, this particular identity, right? I hope it is pretty simple, you know already, but then also I explain, okay, assuming that you should, if by chance you don't know, you should be having clarity on this, right? So perfect, right? Now as it is told, okay, it is true, identities are true for every single variable value of variables, right? You can put here 1000, you can put here 0.001, you can put like it is going to be true. What is the meaning here? 0.1, 0.2, right? So what is that? 0.3. 0.1, 0.2 is 0.3 addition. If you do 0.3 square is what? 0.09. Now you put here 0.1 square, then 2 into 0.1 into 0.2 plus 0.2 square, right? You do that again, and it is going to give you the true result, as LHS is going to be equals to RHS. So this is what really important, very basic identity. We need to remember it. Now we come to x minus y whole square. So in it is, what is the difference here? It was plus and this is minus. So what we can write down here, we can change it to this format: x plus minus y. Tell me, if I write x plus minus y, it is indirectly what? Indirectly it is x minus y only. So this identity, this whole square I want to do. So what I'll do here, x square plus 2 times of x times minus y plus minus y square. So what do we get? X square. This minus will change this plus. So 2xy plus minus y square is what? Y square only. So this is what we are getting, right? So what do we get? First term. There are two terms here. You can see clearly in this bracket, there are two terms. First term, second term. So first term square, second term square, and product of them got double. Right? That's what you need to remember. Right? Now this identity x square minus y square is what? X plus y and x minus y. What happens here? It is like this only, right? X plus y only. But what happens? It is just minus here, right? The minus is what? Here. So when I multiply x to this xy, I'm going to get the same thing. But when I'm going to do minus here and I'm going to multiply this here, it is what? Minus here and minus here, right? This will change to minus. So xy will get cancelled and we'll get minus y squared. That's how it is coming, right? So this is again very, very important identity, right? I can show you the example also here. What example I can take? Suppose I need to do 101. Yes, you can take any number, by the way. But suppose like 101 square minus 99 square. Now, if you're going to do the way like 101 square, you will multiply, you'll take time here, right? You're going to take time. But using this identity, life becomes easy, right? Using this identity, we can make our life simple, right? Oh, is it like 101 square? It looks like, okay, I need to do that. Okay, 99 square. That is also like little bit complicated to do, right? No problem. This identity is there to rescue us, right? Okay, this is what. So I can apply, right? X is what? 101. Y is what? 99. So 101 plus 99 and 101 minus 99. Right? What is this identity saying? If there are two numbers written like that, squares of them are subtracted, add them into subtract them. That's all, right? This is what we need to do. So it is what? This is what? Very good number now, 200. And this is what here? 2. Perfect. Answer is very easy, 400. Wow. It looks nice, right? Compared to doing this work, squaring this and subtracting, this is pretty easy work, right? Compared to the above work, which one? This is what? Pretty easy work, right? So this is how it is going to help us, right? Now it is x plus a, x plus b. This is what? X square ab, x square, these two ka product, ab, and in between x times a will be there and x times b will be there. So x common, a plus b, right? You can verify again by multiplying individually. You can verify the identity. Yes. Okay, now there are three terms and we are squaring it. Three terms are there and we want to square them. So okay, what do we do? X square, y square, z square, like we do here also. Here only two terms were there, so 2xy. But here 2yz and 2xz will come, right? Now how do we prove this? Okay, so what we can do here, you make the grouping here, right? This is what, like first this is like one term here for you. So this square plus this square and their product ka double, right? That is what you can do. And then individually, so you can prove, I believe you got the idea, right? You can take this as 1a and then a square plus z square plus 2az and then put a back. So you can open that using above identity and you will get this, right? I hope it is easy. Next one, x plus y whole cube. So now you might be wondering again how it is coming. No problem. Break it down. X plus y whole square we have seen. into x plus y. We can write down like this. Open this whole square using above identity and then multiply this. You will be getting this expression, right? Now minus is simple, as I told you, plus into minus y, and then you can write down this one, right? I hope it is easy. This is how we are going to do it. Now this last identity, which is really very important here, this one is the particular there are many questions they frame because it looks like little bit difficult also to remember, but it is important one. Okay, like we have cubes here, three numbers are there and their cubes are there, minus their product ka three times is there subtracted, then it is what, x plus y plus z, and x square plus y square plus z square minus xy minus yz minus zx, right? This is what it is. So now if you want to prove it, okay, it is little bit like, it is little bit complicated, right? But you can easily go from the right hand side to this side. If you simplify, you're going to get it easily. See, if I multiply x to this whole expression, I'm going to get x cube xy square xz square minus x square y minus yz xyz and minus zx square, right? Similarly, y you multiply, few terms will get cancelled and we are going to get this what, LHS easily. Are you getting me? This is what it is, right? But its use, as I said, okay, it is really very important. Its uses are there, right? This identity, so you have to remember it, right? You can prove it, okay, easily it can be proved, right? So if you, okay, yeah, one more identity which is what not mentioned here, you can say sub part of this identity. If I say x plus y plus z is equals to 0, then x cube plus y cube plus z cube is nothing but 3xyz. X cube plus y cube plus z cube is nothing but 3xyz, right? This one it is. So there are three numbers. If there are three numbers, then you can just simply, if their sum is what? If their sum is what? 0, right? So you can just simply, what if their cubes are asked, okay, how much will their cubes be producing? So that is nothing but their product times 3. That's all. This is what the answer. I hope you got it, right? This is what we need to remember. We need to multiply them all and we need to do 3 times. This is how we do this, right? Okay, wonderful. If you have understood this, we can see more questions based on this identity, right? Let me take the next question. Okay, what are they saying? X square minus 1 using standard algebraic identities. Okay, we need to see here what identities. So subtraction is there and 1 is what? 1 is like very cute number. You can do cube here, you can do 4 times here, you can do like so many things to 1 and then it doesn't change the value or like that. Okay, it is very useful number, right? So that's why what I want to do here, x raised to 4 is there. So can I write down x square to the power 2 and minus 1 square to the power 2, right? Because 1 power 4 is what? I can consider it to be 1 power 4. So this is what it is now. Now we know a square minus b square is what? A plus b and a minus b, right? You need to understand factorization is the process of breaking down into two products, right? Breaking down into two or more products, right? So this is what I can write down here using this identity. X square plus 1 means 1 square, but that is 1 only. X square minus 1 square, right? Now it is x square plus 1. We cannot factorize this further because it is plus, but this thing can be applied again identity right here. So x plus 1 and x minus 1. So this is what our answer, right? This is how we do it. You can see here. Now here only, can I take, can I utilize this space to give you one question based on the previous identity? Suppose I have 5 cube, then 6 cube, and minus 11 cube, right? You can see. This 5 cube is okay, fine. It will be 125. 6 cube will be 36 into 6, which is 216. 1 cube will be what? 121 into 11, right? So if I do it directly, it is what? 125. 5 cube is 125 plus 6 cube is what? 216 minus 11 cube. 11 into 11 into 11 is what? 121 into 11, which is what? 11 ones are 11, then 11 twos are 22 and 1. So 3, then 11 ones are, and then 1, 3, 3, 1 we are getting. Right? This is what we got. Now, what do we have here? 1. Then here 3, 4. Right here. Now here 3. Right? This is what we got. Now minus 1, 3, 3, 1. It is what? Okay, I can subtract, right? Minus what I need to do? 3, 4, 1. So 0. Then here 9. Then here 9. Okay, very good. We got minus 990, right? So I had to do the cubes. Though, like, I just wrote this question, so I just took the even small numbers. We can have more numbers. We can plan to have very good question on this, and there are questions on this. I just took the example roughly. So there is one way. Okay, this is what we do, but we don't want to do this. We want to use the identity, right? Using identity, we want to do identity. This is without identity. This is what I did without the identity. So I want to learn using identity. How can I do without identity? Right. So now I can take 5 cube plus 6 cube plus minus 11 to the power 3. Right. Now you can see what are the numbers here. Can you see which identity is going to fit here? This particular identity, right? X plus y plus z is what? When it is x plus y plus z is equals to 0, so I can say cubes are equals to 3 times of x, y, z, right? So you can see x is equals to 5 here, and y is equals to 6 here, z is equals to minus 11 here. What is the sum of these? 5 plus 6 minus 11 is equals to 0, right? Perfect. So we know it is what? If x plus y plus z is equals to 0, x cube plus y cube plus z cube is gonna give us 3xyz. I hope you're understanding this. So that's why you don't need to do this stuff. You can just write down answer as 3 times of x, which is what? 5 into 6 into minus 11. Minus 11, right? Not 11, minus 11. With sign we need to write. So what are we getting here? 30 here. 30 into 3, 90 into what? Minus 11, and 11 nines are 99. Very good. I hope we are getting I wrote the identities and all, but answer is pretty fast this way compared to this work, right? We need to do addition, multiplication, little bit. And imagine if your numbers are bigger, right? I just took small numbers still, right? So this is what I just wanted to show you, the use of this particular identity, the last one. Okay, this is really important, right? Okay, let's move on to next topic, division of polynomials. I think I have shown the division of polynomials in previous lectures also. If you have watched it, okay, it's fine. If you understand it, it is gonna less time. But if you have doubt, okay, let's understand this further. There is no problem, right, in understanding it again and again. And that's how we learn with the maths. Okay, we do the things repeatedly, right? So we need to do here long division. So I showed it already, but let me repeat it for you to give you more understanding here. We need to do long division here. And we have seen how we can avoid the long division by factor theorem, remainder theorem, right? So what we do here we need to generate this. First of all, write the terms in the order. If any missing term is there, Missing term, I mean x square is there, x power 1 is there, and x power 0 is there. Decreasing order of the standard format of the polynomial we need to write. And if any missing term is there, missing term means x power, suppose it is x square plus 21, and there is no x term, right? You add it, 0 times x. You add that term. It will be like this way. If you do, you can avoid these silly mistakes there, right? So that's why you should do this like this way always. I would suggest every time you add, okay, if any missing term is there, right, in the divisor or in the dividend, anywhere, right? So what is the quotient I should write so that I can generate x square? So x square, and then x times 7, so 7x, and then we subtract minus here. So this is getting cancelled. What are we getting? 3x. We need to change the sign while subtracting. Remember that, 3x plus 21. Now what should I do here? What I need to write here? 3, right? Because I need to generate 3x here. 3 times x plus 3 sevens are 21. So remainder is 0 because minus here, right? This is what the quotient. This is what long division, right? This is what we know as long division of polynomials, right? You can see here. Perfect. These steps are given, but I think you can proceed without reading out this much. Okay, like, okay. Now factorize the polynomial using standard algebraic identities. We can do this question. Now you can see, like, it is related to which particular identity. Can you see here the expression? Can I give you the hint here? Can I give you the hint here? Can I write here 4 times of x square, then 2y square plus 3z complete square minus, okay, now here minus is there. Now you need to be careful here, right? So if it is yes, now if it is you can see here, if I write here minus, is there any change? No, right? There is no change. But that is what we write here. Which identity you can relate it to? A square plus b square plus c square plus 2ab plus 2bc plus 2ca. That is what a plus b plus c. I wrote it reverse way actually, but I think you can remember. Both ways we need to remember, and that's what we need to do here. We need to write it reverse way. So here a is what? Minus 4x, b is what? 2y, and c is what? 3z. So here it has to be 2ab. So this is what? Negative, right? 2ab. So can I write here 2 times of, you can write here like this, minus 4x, and b is what? 2y. Can you see? 2 into 2, 4, 4 and 4, 16, minus 16 xy, right? Then here 2bc, 2bc, like this here, this product here, plus 2 times of 2y, oh my bad, 3z, 2y plus 3z, 2y, 3z, right? This is what it is there. Then plus 2 times of ca. C is what? 3z and minus 4y. Can you 4x, sorry. Yeah, can you relate it? Everything, is it producing the same thing? Yes, exactly. So indirectly, what is it written? It is nothing but minus 4x plus 2y plus 3z whole square. Okay, and we need to write the factorized form, so that's why minus 4x plus 2y plus 3z into minus 4x plus 2y plus 3z. Okay, this is what factorized form. So using standard limits only, we factorized it. Find the product of this using algebraic identities here, right? Okay, it is what? X plus 1 whole square, right? So it is x square plus 2x plus 1 square. Yes, evaluate this. We need to do long division here, right? So 23y square. I said you write the polynomial dividend in the standard format, okay, right? So that's why, like, 13y, decreasing order we need to maintain here, 20y cube. Yes, this is what it is. This is my dividend. And here 5y square minus 3y plus 2. Let's divide it now. So how much should I write here? 4y. So that 20 y cube we will get. And then here minus 12y square. Then here plus 8y. So change the sign, minus plus minus. It will get cancelled. What are we getting here? Right? I hope you're understanding this. Okay, tell me. 5, 35y square, then minus 21y plus 9. Now, what should I do further? What should I multiply by? I need to multiply by 7, right? 7, 35y square minus 21y and then 14 minus plus minus. So this is getting cancelled, and what are we getting? Minus 5. This is what are minus 5, right? This is what we are getting, right? I hope you understand this, right? Okay, so yes, that is what the answer we are getting, right? I hope you enjoyed. Okay, I think we have one more lecture. Okay, we have covered. Watch all the lectures from the polynomials and let me know if any doubt is there to anyone, right? Thank you very much. See you in the next lecture. Bye bye.